So my name is Jeff Costello, and I'm here to talk to you about something that I find really, really important. And before I get to that, all the doom and gloom of the disasters that I'm going to talk about, I'm going to talk a little bit about myself, because the reason that I'm here and the windy path that I've taken through my university career has given me the insight to give you the talk that I'm going to give today. So my windy road. So I originally came from Calgary 4 years ago, and I came to UBC because it's beautiful and it's BC and all that great stuff. I was a really big science nerd. So the first thing I did was I went into the Science 1 program, which is a really, really great program. It was my first experience with kind of integration. And they try to integrate all the different sciences into one classroom where you can discuss physics with math and physics with biology and all that kind of good stuff. However, for me personally, it was a little bit of a bomb, and my GPA was not appreciative of my trip through Science 1. So the next year when I applied to cell biology and genetics program, I was rejected. But that's okay. It was okay. But I was a little bit lost for a little while, and I really didn't know what I was doing or where I was going or what I wanted to do. So I jumped on an airplane, and I actually took a trip to Nepal. And I lived, go figure. So, and I lived in a little village in Nepal for about 2 months, and I taught school there to the kids, and I learned to speak a little bit of Nepali, and I really became integrated into the society. I lived with a local family on what I guess would be close to $1 or $2 a day, and the experiences I took back from Nepal are really, really relevant to my talk today, but they don't appear so, and it took me a really, really long time to really learn what I had taken away from that trip. But that's just one thing. So when I came back, I started looking, I was like, I gotta figure out what I gotta do. I have to get a degree sometime. So I was looking around, and I immediately became attracted to the integrated science program. And the reason for that was actually because they didn't have a minimum GPA requirement. That's what it started out as. That's what perked my ears to it. But soon after, I realized that this is something that has added immense value to my degree. So what you do in integrated science is you get to pick various specialties in science to integrate. So I'm integrating, as all our eyesight kids say, I'm integrating virology, population and ecology, and quantitative genetics. So that's kind of what I do, which really doesn't mean a lot. At the same time, I got involved in the Science Undergraduate Society, which is great. And SUS is a fantastic organization with fantastic people running it. And I got to actually talk to students about what their degree means to them and the path that they're taking to their future. I've also always been a political junkie, so I had to get involved in political science somehow. I took Alan Sens' course, and I loved it, and I got involved in political science, so I applied to do a double major in that. So where does that leave me now? Well, at one point in time, I wanted to go to med school, and I don't have the GPA into there. And I also wanted to go to law school, but I probably won't get into there either. That doesn't mean I'm not going to be successful, because I really have a feeling that I am. I just don't know what in yet. And that's okay, too. So what am I here to talk to you about today? Well, I'm here to talk to you about when I come from both of the sides, the arts and the sciences, and all of my experiences, I realize that there's a huge divide in how we think about issues in our world. And this is a little example that I'll take you through. So this is a well-known kind of symbiosis, as well-studied symbiosis in ecology. So what we have here are microbes, and they fix the nitrogen in the air, the N2, into a more usable form of nitrogen that the tree needs to survive. So the tree gets nitrogen from the microbes, and at the same time, the tree is giving sources of carbon to the microbes so that they can go through their metabolism and then their life cycle. So we can say a couple things about the characteristics. And trees have a long lifespan. The cells inside of trees are quite large and take up a lot of energy, and they're not very susceptible to environmental damage. Trees tend to live a long time, and no matter what is happening in the world around them. Microbes, on the other hand, have a very short lifespan, comparatively. They're susceptible to environmental damages. They live in a larger and denser population. They're always in a boom and bust. And they use fewer resources per unit. So we looked at this, and it's a really well-studied phenomenon in ecology, and a lot of you poli-sci students probably haven't heard of it, which isn't surprising, and that's kind of what I'm getting at. So we have people like David Suzuki and other environmentalists who say that this model relationship, this symbiosis, is a good relationship. It forms a natural balance. Everything's nicely in order, and everybody can survive, and it's a model for humans. So this is where we come to this divide. So what I'm going to do is I'm going to change two pictures on the slide, and hopefully you'll see what I'm trying to get at. And just try to feel that shift that's going to happen in your head when I change them. So we can say similar things about the relationship between the global north and the global south, or the developed world and the underdeveloped world. That's not to say that the two relationships are identical, of course, but we can use ecological talk and compare the two relationships between each other. And I think that this is a really, really useful useful way to do it. And we don't use science and ecology and evolution in everyday society talk. When we talk about political issues, we don't think about them from the perspective of a scientist. And the interesting thing about this relationship is that people say the exact opposite thing about it, is that it's a bad relationship. It's unfair and unbalanced, and a lot of times people say it's predatory, and it's not going to be sustainable for our future. And that may well be true, but it's interesting to think that the same people saying that are the ones saying it was also good when you see it in an ecological framework. So we really have to get our head around what are people doing and what are human and what is nature doing. And there's a huge disconnect about how people think about systems in terms of political ideas and ecological evolutionary ideas. And so I just want to reiterate, I'm not trying to say that these two relationships are exactly the same, but there are certainly comparisons we can make between them, and we don't do that often enough. So why is this important? Well, the divide that I'm talking about is, students have a very one-dimensional aspect, and a lot of the speakers have touched on this today. We kind of come through with one faculty and one specialization. We really know our stuff there because we've memorized, and we forget. We really only have one framework in which we can talk about that. And so universities are failing to ensure that students have the required skills that they need, and the science needs to be taught in the classroom so they can be applied to social problems. And what happens is we have science and society right beside each other, and that's the ideal picture. But in reality, this is what's happened. We've taken science and we've thrown it into the corner, and we've said, you go in your ivory tower, and you go do your thing, and you go work with technologies, and society will work out these problems. Poverty, global warming, clean water, all of these things are huge issues that face society, and yet we don't turn around and ask scientists and ask science, what should we do? And it's not that science has the answers either, but we have to talk to anybody. Instead, we rely on science to produce technologies for us, new innovations and technologies, but that's not enough. That's an important part of what science does, but science is also about education. Science is about problem solving, and we need to be more active in using science and the good things about science to solve our everyday problems. So where can we start to do this? Where can we start to bridge this divide between the two? Well, here's a really easy one that hopefully a lot of people can relate to. So guys in the audience, what are you thinking about right now? So on average, 25 of you are thinking about sex right now. So sex is a great one to talk about because evolutionary biologists and ecologists love to talk about sex. And society has a fascination with sex, although the two think of them on a very, very different level. From biologists, I think of sex as one of the most important times in an organism's life when it passes on its genetic material to another generation. And a lot of people in the societal kind of framework think of it as just a way to sell things. And they think of it as kind of a tool that gets used against us. And it's true, it absolutely is true that companies are using sex and our innermost desires to actually sell us a product. And is this a bad thing to do? Because a lot of people turn around and say that no, it's not fair. They shouldn't be capitalizing on our kind of instincts. So yes, they absolutely are capitalizing on it, but is this a new strategy? Is this something that companies have been doing just recently? Well, no. And the reason that I'll point to for that is salmon in spawning colors. So salmon are a really, really cool organism, and they live in saltwater and freshwater. And when they leave the ocean and they start to swim up the river to where their spawning ground is, they change color into this bright red color. And so when I saw this, the first thing I asked was, well, why red? Well, they're changing colors so they can be attracted to a mate, that they can try to find somebody who they can share their gametes with and pass on their genetic material. But why red? So why not turn yellow or silver or blue? Why was it red? And the reason why it's red is actually because if you were a fish and you had fish eyes, they see color a lot differently than we do. And they actually pick up red better than they pick up any other color. Silvers are lost. Blues and greens are generally lost, but reds really stand out. So really what's happened here is a process that geneticists and evolutionists will call sensory drive. And natural selection is actually capitalized on the fact that fish see red so well, so that's the best color to turn myself. So they're really doing the same thing that the corporations are doing. They're hijacking our nature and our instincts to be as appealing as possible to other mates. Another example that's actually really been well studied and seems really weird to me, but people study bird songs all the time in biology. And so this is an example of bird songs from males and female nuthatches. So the males tend to sing to the females to try to attract a mate. And so a low pitch, so for all you non-science people, a low pitch is like a low pitch, and a high pitch is like a high pitch. And so And the most optimum place to actually sing if you're a male is somewhere between 2.7 and 3.7 kilohertz. And that doesn't really matter, but what does matter is that there's an optimum range in which females will respond best to that song. So those males who sing there, they have a successful song and they have a good chance to find a friend, and the other ones don't. They have a less successful chance to find a friend. So this is what I'm going to do is I'm going to do the same thing that I did in one of the first slides, and I'm just going to change a little bit of it, and we'll see what we're talking about, so we can make a connection. So now we're talking about advertisements. And I'm not a marketing major. You should talk to Alan about this because I don't really know. But I would assume that if you're a programmer and you're deciding how many television ads to run in an hour, there's a happy medium, because if you put too many on, you'll turn people off. And if you put too few on, then you won't get people's attention. So there's obviously the same thing. There's an optimum range of what you want to put ads on. So really, this process and this strategy that marketing companies use is exactly the same as the strategies that fish use in terms of finding a mate and nuthatches use to find a mate. So corporations use these strategies the same way we do, and there's really no difference between them. I'm sure a marketing major could understand the evolutionary and ecological impacts of that strategy just as well as I do it the backwards way. But they don't. We don't have to do that in our classroom. So what's another thing that we can talk about? Well, racism. And some people have touched on racism today. And I really wanted to it's a hot topic nowadays. Barack Obama winning the White House is a phenomenal achievement for civil rights, and there's no doubt about that. But racism is still prevalent. And as long as we have recorded history, we've noticed that people wage war on each other for no reason other than skin color. And so why is this? It's not a new phenomenon. It's something we have seen in the past and we continue to see today, is that racism is an unfortunate reality of the world that we live in, and we try to fight against it, but there's always seemed to be this racial undertone. So if that's true, then why are we racist? Why is there something inside of us that makes us untrustful of people who look different than us or talk differently than us? And is there a biological explanation for this? And so what I'm trying to do here is I'm trying to explain a social phenomenon, something like racism, through a biological explanation. And so I'm not trying to condone racism. I think it's horrible. But we do have to look at it as if it has to be rational at some point, or it never would have evolved between us. So let's look into this. So here's a little game for girls to play. Whose face looks better? Which face is more attractive? And the reason it's tough to do, but this is actually a psychological experiment that's been done a lot of times. And what they do is they'll change one of the faces just a little tiny bit. They'll maybe move the eyes apart a little bit, the mouth down, the chin up, so that your brain instinctively will tell you which face looks better. But when you ask people, why does that face look better? They can't tell you. They just have a gut feeling. They just kind of know that one face looks better than the other, and they can't explain to you why. And so what's actually happening here is our brain is processing and has a huge potential to be able to process a face and be able to analyze it very, very quickly. And so our brain is analyzing people's faces and instinctively telling us whether it's a good face or a bad face in our subconscious. It's subconsciously doing more processing than it is conscious processing. So could this subconscious processing be the root cause of racism? Could it be that there was a subconscious thing programmed into our brain to tell us not to trust people or not to associate with people based off of what our brain is looking? It doesn't make sense to our, what we think and what we feel, but there's something in our head that may be doing this and may be driving all of this conflict. So why would this have helped us in the past? Well, you can imagine on the next slide, I'm going to talk about Jane Goodall. And this is a bit of a foray into something else, but Jane Goodall is she's spent her whole life with chimpanzees, and she's one of the premier biologists in the whole world on the study of chimpanzees, which are our closest genetic link. And what she did was she took a study, and when biologists do studies, they go out into the field, maybe they should go out into the jungle, and they'll sit and they'll watch the chimpanzees. And they'll watch them and they'll take notes for hours and hours and hours. They might only be looking for one trait, one kind of thing that their study focuses on, but they take notes on everything. And then they throw out most of what they've taken and only take out of it what they were looking for. So what Jane Goodall did with a whole bunch of other biologists was they took 7 of these major studies, which together accumulated for 151 years of observation on chimpanzees. And they tried to take some of the observations and categorize them into geography. And what they found was chimp culture. So if you look at a map, and what they can actually do, and I'll show you the map in a second, is that they can take different groups of monkeys, or chimpanzees, and compare them based off of their culture. So things like culture are picking your nose with a stick, knocking on wood to get people's attention. Some groups actually do a little dance when it starts raining, believe it or not, and whether or not monkeys clasp hands with each other when they play. So these are an example of culture, and this paper, when I read it last year, really caught my attention, because what we're doing is we're taking this leap from a social thing that we think of, like culture, and transforming it into something that maybe has a biological purpose. So this is that map that I was talking about, and they managed to notice these 6 groups and put them together. So we think of culture as a uniquely human phenomenon, but does it exist in other people? Does it exist in other organisms? So, and what purpose could it have had? Well, here's my example with culture to kind of bring culture together with that subconscious process. So when I was living in Nepal and I was living in this little village, I lived with a family, like I said, I taught in the local school and I was learning to speak some Nepali. The whole time I was there, when I asked people questions and they would respond to me, they'd go like this, cha? And the whole time, and I was like, okay, I get it, but she's not really sure what she's, telling me. And it turns out that in Southeast Asia, a lot of cultures don't nod yes, they go like this. And so for a month and a half, I was sitting there, and every time I asked somebody a question, I thought they weren't sure of the answer they were giving me. And I couldn't really understand this until I sat down with somebody and was like, okay, when you do this, do you mean yes? And she was like, yeah, you didn't know that? And I said, no, I didn't know that. I'm just figuring that out now. So this is a perfect example of subliminal culture. So no matter what color my skin was, and no matter what language I spoke, I would still be immediately viewed as an outsider because I don't understand the subtleness of some of the cultural traits we have. So, and that's just one example. The way I use my hands when I talk, the way I look at people when I first meet them, these could all be traits that our brain is subliminally analyzing and deciding whether this person is a friend or foe. And why would that have been useful? Why would that have ever evolved in humans? Well, probably because if we were to take it back thousands of years ago when we were living in local tribes, you had to know who to trust and who not to trust. And you had to be able to recognize that immediately because you were so reliant on the people around you for survival. So then that leaves us with this. Could racism, what we see, actually be a vestigial trait? So could it actually be just an adaptation that was useful to us at some level thousands and thousands of years ago, and now it's just kind of there, like a tailbone, or an appendix? And this may seem kind of controversial, and it may I'm not trying to accept racism, but I'm saying that we have to be able to look at social problems from a biological perspective to try to gain insight on them. And I've never seen this analysis. This is analysis I came up with myself, and UBC tells me that I'm really, really not very good on my report card, so it's probably wrong. But I've never seen anybody try to do it. So I try to do it because that's how I think. So why are evolution and ecology important to us? Well, science has a lot of important things to say about the human condition. And we've neglected it, and we've thrown it into the lab, and we've said, no, you do the lab work because it revolves math, and nobody wants to do math, so you guys do the math, and we'll deal with all the social problems, the real people problems. And that's not the way that we should do it. Science is failing. And why is science failing? Because we measure science in the number of technologies we produce, the amount of papers we put out, and the amount of funding we get. What we don't measure science in is science education, of whether people are actually being able to understand science and apply it to their everyday life. And we just aren't there. 80% of the population isn't scientifically literate and doesn't properly understand science and what it can offer. So the disciplines of academia have to move closer together to help to solve this. We talk a lot about globalization in politics classes, and globalization is happening all over the world. You look at the global economies all collapsing together because they're so interrelated. We look at cultures being able to move and exchange with each other at a rate that we can't even comprehend because of the internet. And yet somehow we've allowed ourselves in the academia to put science and the arts and these different faculties and to continue to spread them farther and farther apart. The only way we're going to be able to solve these problems is by bringing them closer together. We have to mirror this global movement. So what's going on with UBC? And I can only speak as a science student because that's where I've spent most of my time. But UBC is one of the most highly regarded universities in the world, 34th, I think, on that really important list that all those people look at. So, and yet at UBC in science, I feel that science students don't care about science. They see it as a stepping stone. It's the way that they get into med school. And I'll tell you, science is the wave of the delusional. There are so many students. There's got to be 1,000 students in the faculty who believe I'm getting into med school, and there's only 180, 200 spots. It's just not going to happen, and yet we're not preparing students to do anything more than memorize and write and regurgitate on exams. So social discussions are taking place in science classrooms, but they're done on a memorize it and just spit it back out basis. It's not done any differently than memorizing the inside of a cell. It's just done on, this is global warming, these are the issues, these are the potential solutions, and then they ask the same question on the exam. And that's just not good enough. There's going to be problems that we're going to be faced with in the future that are not going to be reliant on what we've learned in the past. And we have to be able to adapt and use the technologies and the techniques that we've used in science to solve those. 1,427 new science students entered the faculty this year in first year, and yet somehow there are only 40 spots in biological ethics classes, Biology 442, in the Faculty of Science. This is an absolute disgrace upon the university and upon this faculty. It shows the level that they care about us actually applying what we're learning to real world issues. They saying that, it's okay, we'll leave it till grad school for people to learn about ethics, and that's just not good enough. We have to be doing better than this and teaching people that what they're learning in class is important to them and the people around them and society as a whole. And these are some of the UBC 2010 learning goals. The UBC has decided that they want to foster a sense of social awareness and global responsibility. And I've already gone through, I just don't think that's happening. They talk about it like it's happening. No, they do, and I'm being serious now. They talk about it like it's happening, but it's not, because students are less able to turn out and vote in our elections. And students are less able to discuss issues that are relevant to all of us. They want to review the methods by which teaching is delivered. And the only change I've seen in this is the PRS, or the eye clicker if you're in science, which is basically just a way to get you in classrooms and press a button. But it really doesn't engage us, and we need to be engaged, and we need to find out why what we're learning is important to everybody. So they've also, I believe, failed at that. So the other thing that I'm hoping that they will start to do is supporting innovation and improvements in teaching, and telling people that there are new technologies and we need to expand our horizons. And I don't know if they're going to support that yet, but I sure hope they are, because that leads me to my wish. So the wish that I'd like to make would be to create something of an infrastructure, I guess would be the way to call it, and it's called IF, which stands for Integrated Forum. It's also a great way to sell the program, because you'd be like, what if? So that's really, I'm just that marketing guy in me, So what is the Integrated Forum? So it's a forum where students can come together and talk about issues that are happening in their faculty and issues that are happening across our university, and try to adjust them and try to bring people together to discuss their ideas. But it does more than that. So students will have a personal profile similar to Facebook. So if you're here for Andre's talk, he talked a lot about this, and he wanted people to become more personal in their educational space and understand who their classmates were, and that will start doing this. It'll include current course discussions. So a lot of people right now have course discussions on Vista or WebCT or some other website. And what we can do is we can bring all these discussions together and put them in one spot. And I can go as a science student and look at a discussion happening in a political science class and read through it and maybe partake in it as well. And that will help me, to get information from all these faculties. And this is the really big one that I want IF to do. So courses will be able to do cross-faculty assignments. So I have a roommate who's in mechanical engineering, and he's in a medical technologies class. And in all his time in this class, he has not yet talked to a medical student at this university. I think that's a terrible waste of resources. I mean, medical students are interested in learning about what the future of medicine is going to look like, and the engineers are going to help provide us with those technologies. So why can't we put them in the same room or in the same virtual room and discuss what the possible options are? So it's going to also link to student resources. So hopefully something like a mini Wikipedia for UBC students, a place where you can go to find information about how do genetics work, how does a cell grow, how do we elect our government. All those kind of important things will be accessible to students to hopefully foster more information sharing. And at the end of the year, I really hope to hold another conference, similar to this one, where we bring together politicians, and we bring together scientists, and we force them to talk about these issues and see what everybody has to say at the table and not push some people aside in favor of others. If it is successful, we can expand it overseas. We can bring this virtual classroom to other people. And this isn't a new idea, but I think it's something that we could look forward to in the future. And again, the really important thing is I want to see people being able to do assignments in their classrooms for courses, for course marks. People won't use the integrated forum unless it's for marks. That's the reality of student life, is that they won't look outside their box until you tell them to, for most students. Probably not the people here. But for most students, if you happen to see this, you don't look outside the box. We have to kind of force them to that. And we have to say, now go and work together and get people's opinions, so that you have to do that to get a mark. And that's how we could really, base our university grades on. So to provide a framework for courses to interact with each other and learn with each other. And that's my wish. So thank you very much for having me here, and it's been fantastic.